Good afternoon, students of class 10th. Yesterday, we defined what electricity is. Today, we are going to learn what is the atomic theory of electric current. We just stated that electric current means the flow of charges through a conductor. Okay, what are the type of charges which are going to flow through the conductor is explained today in the topic atomic theory of electric current. Well, now let us consider this is a portion of a copper wire. XY is a portion of the copper wire. Is copper a conductor or insulator? Yes, good. It is a very good conductor. So it will allow the flow of electric charges. Yesterday I taught you conventional current means the flow of positive charges. Now inside the copper wire, it is made up of copper atoms. So all the atoms of copper are very tightly or very closely packed with each other. In such a situation, what will happen? Every atom is made up of what? Positively charged nucleus and negatively charged electrons. Out of these, the positively charged nucleus contains what? The protons and the neutrons. So who gives the positive charge to the nucleus? Yes, it is the protons. That's good. Where are the protons located inside the nucleus? Okay, very tightly bound along with the neutrons. So they cannot easily come out of the nucleus. So there is no chance for the flow of the positive charges in any atom. Okay. Where are the electrons located in an atom? Good. Yes, they are outside the nucleus. What are they doing around the nucleus? That's also good. Yes, they are revolving around the nucleus in various circular orbits. Good. Now, are they bound to the nucleus or loosely attached? Okay, that's also correct. Only the innermost electrons will be tightly bound to the nucleus, whereas the outermost electrons, which are otherwise called as the valence electrons, are very loosely attached to the nucleus, and these electrons can be called as free electrons. Now you can all look at the board. I have taken a very small length of a copper wire. One end is X and the other end is Y. Inside, when all the copper atoms are very tightly bound with each other, the outermost electrons of one atom will enter into the region of the other atom. As a result, what will happen? The electrons, the outermost electrons of all the atoms will be disturbed, and they will be moving like stray electrons in between the two ends X and Y. So these outermost electrons only are free to move about and not the innermost electrons. These outermost electrons present in every copper atom is going to contribute for electrical conduction. That is why these outermost electrons are having two names. One is they are called as free electrons. Why they are called as free electrons? Because they come out of the influence of the nucleus. They are free to move about the conductor between the two ends X and Y. Okay. What is the other name I told for the free electrons? Yes, good. Conduction electrons. Yes. Why? Why I am giving another name for these electrons as conduction electrons? Because these free electrons only are responsible for the conduction of current through a conductor. So free electrons are otherwise called as conduction electrons. Now, you look at the board once again. I have represented these red circles with positive sign. This means the nucleus of all the copper atoms. I have represented these dots as the negatively charged electrons. Okay. So what is the charge associated with an electron? Is an electron positive or negative? Very good. Electrons are negatively charged. That is why they are attracted towards the positively charged nucleus. Okay, good. Now, in this picture, you see that each electron indicated by these blue dots are moving in different directions. Are they moving in same direction or different direction? Yes, they are all moving in different directions. So this type of motion is called as random motion. Random motion of the electrons. Random motion of the negatively charged electrons. Now the moment these electric charges, namely the free electrons, will move from one point to other point, a current will be produced. So a very feeble current will be produced by each electron. So now the first electron is moving towards the left and the next electron is moving in the downward inclined direction. Like that, the third electron, you see that it is moving in the upward direction. Like this, if you look at all the free electrons available between the two ends x and y, all these electrons, outermost electrons called as the free electrons, will move in different directions with the different velocities. Okay. So, are they moving or not? Yes, they are moving. The moment the electrons will move, a current will be produced, I said. When each electron produces a current means, then every electron will produce some portion of the fractional current. Okay, so what will be the total current in the conductor? When every electron is contributing some current to the conductor, then the total current passing through the conductor must be equal to what? The sum of all the currents. But will the current flow in the same direction or different directions? Yes, you are right. Since the electrons are moving in different directions, the current produced by each and every electron will also be in different directions. So if you add the current contributed by every electron, the total current in the conductor will be equal to 0. So I will write that the total current flowing in the conductor is equal to 0. What is the reason for this? This is because of the random motion of the electrons. Okay. You imagine. For example, a huge rock has to be pulled. A huge rock has to be pulled by a rope. Some 100 persons are involved in this task. Imagine if the rock is being pulled by 100 persons and each person is pulling the rope in different directions as he wishes, means can there be a movement of the rock? Yes, it cannot move. Imagine if the same rock is being pulled by the same rope by all these 100 persons in the same direction. If they apply force, then what can you imagine? Yes, very good answer. The rock will definitely move. This is because when the forces are applied in random directions, the net force will be equal to 0. Like that, if all the forces act in the same direction, then the net force acting on the rock will be added up. Like that. Now, we want to make all the electrons to move in a single direction. Then only there can be a net current in the conductor. Okay. Can you take a hammer and hit the conductor to make the electrons to flow? No, the wire will be cut off. Can you imagine any other method of making all the electrons to flow in a single direction? You imagine what charge do the electrons have? Yes, they have a negative charge. So, if you apply a positive potential at one end and a negative potential at another end of the conductor, certainly there will be a potential difference across the conductor and we can make all the electrons to flow in a single direction. So, that is depicted in the second picture. Can you all see the second picture? In the second picture, the same conductor made up of copper is connected across a battery. In the previous video, we have seen the combination of two cells is called a battery. So, this one is called a battery. The left end of the battery is connected to the end X. So, what is the potential of this X? Means the X. End X is having a positive potential or positive terminal. And the other end Y is connected to the negative of the battery and hence it is having a negative potential. So, there is a potential difference. There is a potential difference between the two ends of the conductor which is represented by V. This V is the potential difference. Just like water is flowing from a higher potential to a lower potential, a stone or an apple, as observed by Newton, has fallen from a higher position to a lower position. Gases will flow from a higher pressure to a lower pressure. There is always a flow of electric charges from a higher potential to a lower potential. So this is what we have seen. We have seen yesterday as what the conventional current. I is the symbol used for the flow of current. And this is starting from which terminal of the battery? You are right. The current starts from the positive terminal of the battery, and this current only is called by the name what? Conventional current. Okay, but actually, can the positive charges flow? Can the positive charges come out of the nucleus and flow through the conductor? No chance. Then this is by convention. During the invention of current, it was assumed that it is flowing from the positive terminal to the negative terminal. But who is actually responsible for the current flow in the conductor? Yes, it is the free electrons. What charge do the electrons possess? Negative. So what will happen? Towards which potential they will move? Towards the positive potential. In this picture, which end is having a positive potential? You are right. That is the end X is having a positive potential. So the electrons will be moving towards the positive potential. Okay, we continue how the current flows through the conductor. This end A or end X is positive, end Y is negative, and V is the potential difference. V is the potential difference across the conductor. What is I? Already I have told you, it is a conventional current, the flow of positive charges which does not take place. Okay, then what will happen to the free electrons which are negatively charged? Since they are having a negative charge, they will be attracted towards the positive end of the conductor. So since the end X is positive, all the free electrons will be now accelerated, being pulled towards the end X. Can you all see in this picture? I have shown only the electrons by these dots. Are they all going and hitting with the positive ions? These are the positive ions. They are in divide of the free electrons. These are the atoms which have lost the free electrons. They are only called as what? Ions. So the free electrons are attracted towards the positive potential and they are all moving towards the end. What? X. Very good. So the electrons are moving from which potential to which potential? You are right. Electrons are moving from the lower potential towards the higher potential because they are negatively charged. Okay. On the way, there is no open space, there is no free space for the electrons. They have to go through whom? Through the positive ions. This type of motion only is called as drift motion, drift of electrons. So this type of motion only is called as what? Drift of electrons. So they are moving against some struggle, against some opposition, but they will be winning the battle. Finally, they will reach the other end. That's good. So other than these electrons directly hitting with these or colliding with these ions, there will be some other electrons in between. So all these free electrons present in the container, all these conduction electrons present in the conductor will be attracted towards the positive potential, and thereafter they will complete their circuit in the positive terminal of the battery. The electrons will reach the positive terminal. So after that, how the circuit will be completed? The electrons have started from the end Y, they have reached the end X due to the potential difference, and they have passed through the connecting wire and reached the terminal positive of the battery. And how to complete the circuit? They will have to travel inside the battery. There will be some chemicals like dilute sulfuric acid or any other electrolyte through which the electrons will flow. Already these electrons have undergone some collisions with whom? With whom did the electrons undergo collision? Yes, you are right, with the positive ions of copper. During collision, what will happen? This resistance will be developed. There will be some electrical resistance offered to the electrons. So this is only called as what? Resistance of the conductor. So R is the electrical resistance. The electrical resistance. This electrical resistance is provided to the flow of electrons by whom? The collision with the ions. And later we are going to study the relationship between the current flowing through the conductor, potential difference across the conductor, and the resistance offered by the conductor to the flow of free electrons. And have you heard such relation before? Yes, you are right. Yes, that is Ohm's law. Good. Afterwards, in the next lecture, I will explain what is Ohm's law. Graphically also we will study. So in this picture, did you all understand how current flow is taking place? The current flow actually inside the conductor is due to the flow of free electrons from the lower potential to the higher potential. So this only is called as what? The atomic theory of electric current. Okay. Now you tell me what is the unit of electric current in the previous lecture I have told you? Yes, Ampere. Like that, there are some units for potential difference and resistance also. The potential difference V is in volt, and the resistance is having a unit of ohm. Okay. So did you all understand the atomic theory of electric current, students? Hope you must have understood. Now we are going to define what electric current in a precise manner. So electric current is actually due to the flow of the free electrons from the lower potential towards the higher potential of any electrical conductor. Who is responsible for the potential difference here in the circuit? Who produces a potential difference? Yes, it is a battery. Good, it is a battery. Now we want to study what is electric current. So electric current. Before defining electric current, do you all agree that through the conductor free electrons are flowing? Good. You imagine these electrons can be assumed like water flowing inside a pipe. Yes, we are all having water pipe in our kitchen, bathroom and other rooms and all. What happens when the tap is opened very slowly? A very narrow mouth is opened means what will happen? Yes, good. A large time will be taken for the filling of the container. Suppose if you open the tap very widely, what will happen? Very quickly, the vessel will be completely filled. Yes, like that, what will happen if the electric charges, namely the free electrons, flow through the conductor slowly or very fast? Let us see. Now, electric current. So, through the copper wire, once again, I am considering this is a cross section of a copper wire. You must have seen all wires are very long. If you cut any wire and see the cross section, what will be the shape of the cross section? Good. That is a circular cross section. Yes. So, through this circular cross section, just like the water particles are crossing a pipe, who is crossing the cross section inside the conductor is the free electrons. These are the free electrons which are crossing the conductor. And these free electrons are having a quantity of charge. The quantity of charge. So Q is called the quantity of charge associated or quantity of charge flowing through the conductor. And this quantity of charge is equal to what? Integral number of electrons. Integral number of electrons, where E is the charge of electron. E is called what? Charge of electron. What is the type of the charge the electron has? Is it positive or negative? Good, it is negative. And what is the unit of electric charge in the previous video we have seen? It is coulomb. Okay, good. So the charge of the electron is equal to what? 1.6 into 10 to the power of minus 19 coulomb. Okay. So, 1 electron, that is 1.6 into 10 to the power of minus 19 coulomb corresponds to how many electron? 1 electron. Therefore, what must be the charge corresponding to 1 coulomb then equal to? Yes, how will you find? Good, by taking the reciprocal of the value. So this is equal to 1 divided by 1.6 into 10 to the power of minus 19. Roughly speaking, this is equal to 6.25 into 10 to the power of 18 electrons. You see, in only 1 coulomb of charge, though the charge is only 1 coulomb. How many electrons are present? It is 6.25 into 10 raised to the power of 18 number of electrons are present. So these many electrons, bunching of electrons will be passing across the cross section of the conductor each and every second. With high speed they are moving. So this only is called as what? The rate of flow of charges. So current is defined as what? Current is defined as what? The rate of flow of electric charges. The rate of flow of electric charges. What do you mean by rate of flow here? That means current is equal to what? Charges divided by time taken. Electric current is defined as what? The rate of flow of electric charges through the cross section of any conductor. So some coulomb of electrons, some coulomb of free electrons will be crossing the cross section of the wire every instant of time. If you divide the charges, quantity of charges flowing every second, that is the quantity of charge flowing through the conductor by the time taken, this rate of flow of charge only is called as electric current. If the unit of charge is coulomb and the unit of time is a second, then what should be actual unit of electric current must be equal to? Yes, that's good. Coulomb per second. Coulomb per second. Have you ever heard of any other unit for electric current? That is excellent. In the previous video we have seen that Ampere is also another unit of electric current. So this coulomb per second are Ampere. Both are units of what? Electric current. Okay, suppose if Q is equal to 1 coulomb and the time taken is equal to 1 second, means how you will find the electric current? Yes? Yes, good. 1 coulomb divided by 1 second. 1 coulomb divided by 1 second. So 1 ampere is equal to what? 1 coulomb divided by 1 second. So when is the current said to be 1 ampere? How will you define 1 ampere of current? Yes, you try. You try. That is right. That is right. 1 ampere is said to be the electric current when 1 coulomb of charge flows through the conductor for how many seconds? 1 second. Yes, I will repeat once again. So 1 ampere is defined as the electric current flowing through a conductor when 1 coulomb of charge will flow through the cross section for every 1 second. Okay students, today the concept of atomic theory of electricity we have seen, and I want to summarize the very important points once again. Shall we summarize? Good. What will happen when a conductor is not connected to any battery or cell? Can there be an electric current? Yes. Good. There is no electric current. Why? Because the free electrons will be moving in random directions and each electron will contribute some current, but the net current in the conductor will be equal to 0. Okay. So what is the idea we are following? Yes, the two ends should be connected across a battery. What will happen when you connect the two ends of the conductor across the battery? Yes, a potential difference will be produced. In which direction do the free electrons move through the conductor? Towards the positive potential. Good. So there is a potential difference V across the conductor and a current I will flow through the conductor. Normally the conventional current will flow from the positive terminal to the negative terminal. But in which direction do the free electrons flow is opposite to that of the conventional current. So the free electrons will be drifting from the lower potential towards the higher potential. That is, the free electrons will always move from the negative terminal towards the positive terminal in a direction opposite to that of the conventional current. Then what else we have studied? We have defined electric current. Okay. How will you define electric current? Electric current is defined as the rate of flow of electric charges. It is denoted by the symbol capital I. So I equal to Q by T. And the unit of electric current is either coulomb per second or ampere. Lastly, we defined what? 1 ampere. So 1 ampere, how we defined? The current is said to be 1 ampere when 1 coulomb of charge flows through the cross section of the conductor for 1 second. So 1 ampere is also equal to 1 coulomb by 1 second. Okay students, did you all understand the atomic theory of electric current? That's good. If you have any doubt means you can ask me either now or after the class also. Thank you. Thank you very much.